use the given limits to sketch the graph of f. They are all color-coded, so everything is so much easier to follow. Let's go from left to right. On the very left-hand side, we have two yellow limits, so that is limit as x approaches to -2 from the left, y goes to infinity, and x approaches to -2 from the right, y goes to -infinity. So that means there is a vertical asymptote at x equals to -2, right? So we draw a vertical asymptote first. So there you have it. This is my vertical asymptote. So as x approaches to -2 from the left, y goes to infinity, past infinity. That means the curve goes all the way up like that. And then on the left hand side, that is -infinity. So the graph goes all the way down. Okay. And then what's next? So next step, we will be moving to the red. Okay, so when x is equals to x, so I'm going to try follow this. So when x is equals to 4, y is equals to -2. And then when x is equals to -3, y is equals to 0. So x is equals to -3, y is equals to 0. So here, let me fix a typo. So the first one, f of 4 is equals to -2, right? So this one, actually, I copied it wrong for my notes. It should be f of -4 equals to -2. So when x is equals to -4, y is equals to -2. When x is equals to -3, y is equals to 0. So that means we have 2 points. One at 4, -2. So that is like right over here. So that is -4, -2. And the other one is at -3, 0, right? So that is right over here. So -3, 0. And then we have as x approaches to -infinity, we have the y goes to 0. So that means there is a horizontal asymptote at y equals to 0. And then that affects the left end behavior, right? Because we have x approaches to -infinity. So we have something that looks like this. So after -4, -2, the graph should go up to pick up this horizontal asymptote. Let's make that looks nice. So that looks like this. So we have a horizontal asymptote at y equals to 0. And then the yellow curve, this part should join the -3 and the -4. Okay, so let me fix this up a little bit, because when you do this on your paper, I suggest you to use your pencil. So the graph should go down and then join -3 and then join -4 and then go back up to pick up the horizontal asymptote. So now the yellow is done and the red is done. Okay, moving on to the blue, we have f of 0 equals to 0, so that is right at the origin. So we have a point at 0, 0, and then f of 1 is equals to 5. When x is equals to 1, y is equals to 5. So I can see that that is right around there. And then we have a 0, 0. All right, and then one more. As x approaches to 1, y approaches to 2. So as x approaches to 1, y approaches to 2, so that is 1 from either side, right? 1 from either side, y equals to 2. So let me draw, let me make a move. Is this correct? So as x approaches to 1, that is right over here, from either side, y approaches to 2. Is this correct? Is this correct? If that is correct, okay, let me say more. If that is correct, the curve should look like this. I'm going to fix this up a little bit. So this yellow curve will just go up to join the origin and then join the 1, 2. Now, let me ask you this question one more time. Is this correct? Is this function correct? Yes or no? If your answer is a yes, now, if your answer is yes, that means you are saying that this is a function. Let me ask you the next question. Does this pass the vertical line test? What is vertical line test? Vertical line test means you draw a vertical line and there is exactly one intersection. Now, how many do you see? There are 2. That means the vertical line test fails. then this is not a 1-to-1, right? Then this is not 1-to-1. That means this is not a function. Then how do we fix this? How do we fix this? This is not a function. So first of all, look at these 2 points. So we have a 1 comma 5, right? So we have a 1 comma 5. This is a solid point from one of the givens. But the problem is, as x approaches to 1 from either side, should the 2 be a solid point? The answer is no. Since we already have one solid point, then this must be an open circle. So we should just erase this and then change that to an open circle. Because if that is a solid circle, then when x is equals to 1, y is equals to 2, and 5, then this is no longer 1-to-1. This is 1-to-2 because x is assigned to 2 different y values, 1 at 2, 1 at 5. Right? So that's why that must be an open circle. Okay, moving on to the orange. So we have a limit, a point, and another limit. So let's look at the point first. So the point, what do we have? The point, we have 2 comma negative 3, right? So x is equals to 2, y is equals to negative 3. This is a solid point. X is equals to 2, y is equals to negative 3. So as x approaches to 2 from the left, y is equals to 3. So can this be a solid point? No, right? Because we already have a solid point. If this point is solid, like that, if this point is solid, then this is a mistake because x equals to 2 is assigned to 2 different y values, 1 at 3, 1 at negative 3. So that is a mistake. To fix that, we have to use an open circle. So when x is equals to 2, y equals to 3, that is an open circle. All right, and then last thing, as x approaches to infinity, y approaches to, as x approaches to negative infinity. So this one probably is another mistake I copy for my notes. So on my notes, I will positive infinity. So that should be a positive infinity because that affects the right hand behavior, right? So that tells me there is a horizontal asymptote when y is equals to negative 4, which is right over here, right? So we have an horizontal asymptote at y equals to 4, and the graph should look like this. Alright, so this is a pretty common problems you see from many of the textbooks. They give you a bunch of givens, a bunch of limits, and then they give you a bunch of points, and then you need to be able to sketch this graph. Alright, so that is the end of this video. If you think this is helpful, give me a thumbs up. If you are new to the channel, give me a subscribe. If you're on your way out, I will see you all in the next one. Signing out.